Hello class, and welcome to section 9.4, which is about solving quadratic equations using square roots. By the end of today's lesson, you will be able to solve quadratic equations using square roots, including making sure that those answers are in simplified radical form. So, when you are solving with square roots, our goal is to isolate the x squared term. So what I mean by isolate is get the x squared term all by itself. So in this case, this is going to be one of the simplest problems. We've got x squared minus 49 equals 0. To get x squared by itself, I'm going to add 49 to both sides, giving me x squared is equal to 49. Now that the x squared term is by itself, you're going to go ahead and use square root because as we know, square root and square are inverses. So when you do that, you're going to get an answer of x is equal to 7, and you're going to get another answer of x is equal to negative 7. Remember, when you take a square root, there is a positive answer and a negative answer because 7 times 7 is 49 and negative 7 times negative 7 is also 49. So your two solutions to this problem would be 7 and negative 7. You might already encounter some problems that are already set equal or already have that variable isolated. So in this case, you would go ahead and just start by taking the square root of both sides. So I'm going to get x is equal to the square root of 48 or the negative square root of 48. Again, we have that positive and negative answer. If you type the square root of 48 into the calculator, it's going to give you a really long decimal. We don't want that. We want what we call the exact answer. So we're going to leave it as the square root of 48. And now you need to go back to those concepts that we learned in the 9.3 videos about simplifying square roots. So you need to decide if 48 can be divided by any of those numbers on your perfect square list. It so happens that it can. And you can divide 48 by 16. So we can split this into the square root of 16 and 3. And for our second answer, it gets split into, again, 16 and 3. That negative sign is just out front. So your final solutions to this problem are going to be x is equal to 4 square root of 3 is your first possibility. Or for the second one, you're going to get x is equal to negative 4 square root of 3. So we have those simplified versions. So if you can't take the square root, you need to make sure that your answer is in its simplest form using those properties from the 9.3 lessons. Another example here, we've got x squared plus 144. So we'd start by subtracting 144 from both sides to get that x squared term isolated. So we now have x squared is equal to negative 144. If you then take the square root of that and you try to type square root negative 144 into the calculator, it's going to tell you that there are no real solutions. That's because you can't take the square root of a negative number. You can't split it into two equal pieces. So if you are solving and you ever end up with it equaling a negative number, so that x squared is equal to a negative number, the answer is going to be no real solutions. When you get into Algebra 2, you'll start to talk about these things called imaginary solutions, where you can take the square root of a negative number. But for our purposes right now, when you take this square root of a negative number, it's going to give you no real solutions. Go ahead and try this one on your own. Adding 150 to both sides, square rooting that, and then simplifying it down, you get 5 square root of 6 and negative 5 square root of 6 for your answer. In this next problem, again, we need to isolate that x squared. In this case, that means dividing by negative 3. So even though it's set equal to a negative to start, when I divide by negative 3 on both sides, I get x squared is equal to a positive 8. So even if it's initially a negative, you want to go through and make sure that you are solving until you get x squared by itself. Then you can decide if it's positive or negative. So since it's positive now, we're going to square root both sides, and I'm going to get x is equal to the square root of 8, or the negative square root of 8, because we can't actually take the square root of 8. Then you're going to need to simplify. So we get x is equal to the square root of 4 times 2, or negative square root of 4 times 2, which is going to give you answers of x is equal to 2 square roots of 2 for that positive example, or for the second one, x is equal to negative 2 square roots of 2 for that second answer. Go ahead and try this one on your own. Divide both sides by 7, take the square root, and you get positive 4 and negative 4. Another thing that you might encounter is when you divide both sides to isolate that variable, you get x squared is equal to, you can't do 13 divided by 6, so we're going to leave that as a fraction. Then you're going to have to take the square root of both sides. And when you do that, obviously you can't take the square root of that, so I'm going to get x is equal to, remember when you have fractions, you can split it up as square root of 13 over square root of 6, and then you have that negative version, so negative 13 over square root of 6. One thing we learned in those 9-3 videos is that you cannot have a square root on the bottom. So I'm going to go ahead and get rid of that by multiplying the top and the bottom both by square root of 6. When I do that, that's going to give me 78, so the square root of 78 over the square root of 36, and then the negative square root of 78 over the square root of 36. But we all know that we can solve the square root of 36 and get an answer of 6. So then we've got 78, square root of 78 over 6, and negative square root of 78 over 6. You would have to go through and see if you could reduce 78 using a perfect square. In this case, you can't. So these two would be your final answers. Go ahead and try this one on your own. So you got square root of 17 over 5. Then you go ahead and simplify that down, and you're going to end up with square root of 85 over 5 and negative square root of 85 over 5. Last thing, there may be more than one step in order to isolate that variable. If that is the case, make sure you are following your SAD/MEP rules. So I'm going to go ahead and get rid of this 52 first. So I'm going to add 52 to both sides of my equation, giving me 27x squared is equal to 297. Then I'm going to go ahead and divide by 27 on both sides of the equation, and that is going to give me x squared is equal to 11. When I take the square root of both sides, I'm going to get the square root of 11, which can't be simplified, so my answer is x is equal to the square root of 11. And my other answer is x is equal to the negative square root of 11. Go ahead and try this one on your own. Subtracting 130, dividing by 14. Once again, you get 11. So your answers are square root of 11 and negative square root of 11. If you have questions about this or anything else from the lesson, please let me know when you get to class.